Hi everyone. In the three-sum problem, we are going to given an integer array which can contain both negative and positive numbers. We have to find triplets which addition of them is going to give us a sum of 0. So the first thing that we need to do is to sort the entire nums in an ascending order. Now let us take the num value which is currently -1, 0, 1, 2, -1, -4. Once that is done, our values would be, after sorting, it would be -4, -1, -1, 0, 1, and 2. Okay, once that is done, we are going to have a for loop. We are going to have basically three types of pointers, three kind of pointers. So we can have this ith pointer, and the jth pointer would be I plus 1. So let's say we can have this, we can call it as, let's say, I pointer, and the I pointer would be, we are going to loop it through, so all the elements are going to loop it, and we are going to do it till the n-2. And we can have jth pointer, which would be I plus 1, and it will be till the last element. Okay, so we can have this j pointer, and we can have this k pointer to this point. So once we get the 4 right, -4, we are going to make it +4 for the addition, let's say temporary value for now. And now we are going to find addition of both of them. So addition of both of those values is going to result or give us that number. So now if I go out here, right, so addition of this two number is going to give me -1. Okay, so addition of both of them is giving me -1. So if I get it the -1, right, then we have to make a decision, right, and -1 is not equal to temp in any way. So our value, right, -1 is less than 4. Okay, so in that case we have to increment this pointer to this one. This will also give us -4. Again we can increment to this pointer, which is again going to give us 2, which is smaller, and we can again go to this pointer, so it is always going to remain the smaller point, so there is no point of doing it. Now we can have this I pointer at -1, so I would be -1, and j can be starting from this -1 and to 2. So now let's say it will become +1, and these values, right, -1 and 2, it would be forming a sum of +1. So this +1 is going to be the same. So in that way we can basically have we are going to get the first values, which is -1, -1, and 2. The first values we can get, and in this problem statement is written, right, we have to give us the result of all the possible triplets which is going to form the 0, such that it should not contain duplicates. So in order for us to remove the duplicates, we can use a set function in Python that can easily remove the duplicates. Now once that is done, we can again increment our I pointer to -1, and then our j value, right, would be this one, it will be 2. So initially, right, we can have the temp value, which would be minus the current, let's say, array of I, so which is going to become +1. So 0 and 2, right, so if I sum it up, right, the value would be 2. So our temporary variable, right, so 2 is greater than 1. So in that case we are going to decrement the j pointer, so our j pointer is going to come to this position. So 0 plus 1 is 1, and which is equal to temp value. So in that case we are getting our second value, which is -1, 0, and 1. So if I have to write it down, right, how our values would be looking it down. So let's say we can have the values of -4, -1, -1, 0, 1, and 2. So we have to have 3 pointers. So the k pointer, or let's say we can say it as I pointer, which is going to loop it till the 0 index or n-2 index, and then we can have the j pointer, which would be I plus 1, and we can have the k pointer, which would be n-1. And we are going to get the temp value. So temp value would be nothing but -1 of the, let's say, array of I. And now this j and k, right, the summation of both of them, right, in case the summation of both of them is smaller, let's say sum array of j plus array of k. So in case the sum is greater than the temp value, so in that case we are going to decrement our k by -1, and in case the sum is smaller than the temp, in that case we are going to increment our j pointer by 1, and in case the sum is equal to temp, then we are going to store our value to the result. So we can use append function to store it, all the value of array of I, array j, and array of k, basically. So this is the very simple idea. Just to have 3 pointers, and using the 3 pointers we can find our problem. And if I do a complexity, right, it would be close to big O of n square in the worst case, but in the best case it can be big O of n. So our time complexity would be improved a lot. Instead of having 3 loops, we are just having 1 loop, and the second loop is basically just iterating or just checking those values. So in that way our code will be pretty efficient. So let us jump to the Python solution. Now let us initialize a variable called result, which is going to store all the triplets. Now we are going to initialize it as a set just to remove the duplicates in case we found something. Then we are going to sort our nums. So in ascending order, sorted nums. Now we are going to have n, which is going to be length of our nums, and then we are initializing our first pointer. So by way to do it is to have a loop. So for k in range here, right, the way I've explained it could be a little bit different. So you can name your pointers as I, j, k, or you can do it as left or right. It's pretty much your choice how you want to do it. So for k in range 0 to n-2, reason being that we are going to have 2 more pointers, so which is going to cover for the n and n-1. Now we are going to have our first pointer, which is going to be our k plus 1, and our j pointer, which is going to be n-1 initially. Now we are going to have our temporary variable, or can be a target variable, which is going to be minus of nums of k. And now we are going to have a loop while I less than j. Then we're going to have a inner temp inner variable, which is going to the sum of our I and j pointer, which is going to be nums of I plus nums of j pointer. if temp inner is greater than our temp, in that case j would be -1. We are decrementing the j pointer. If our temp inner is less than our temp value, in that case we are going to increment our I pointer by +1, and reason we are doing that increment, right, it's in an ascending order, right? So automatically whichever value would be coming to the next, right, on the from left to right, if our I pointer is incrementing, then the next value will automatically be higher. So by the measure, right, we are going to have a higher value compared to the current temp inner value, right? So our temp inner would be increasing, so increasing our chances to be same as our temp value. In case, right, if none of this is working, so that basically means the temp inner is equal to our temp, so we got our match. So in that case we are going to do res of add of our nums of k, nums of I, and nums of j. And now once we have got our value, so we are going to increment both our I pointer and our j pointer, and at last, right, we are going to return, and instead of sending it as a set, we are going to send it as a list. So let me run the code. There are some issues, let me check it out. Okay, I made a mistake. I am sending this inside this loop. So this was a small error that I did. So you need to be careful on the small issues or the small errors that you make. And let me click on submit. It should submit our code, and let's see if it passes the public test cases. As you could see, it passes the public test cases also. And if I submit it again, I think I'm pretty sure we are going to have a way more higher runtime. I don't know why this issue, because when I last submitted it was like in the 80s range. Because if I look into it, right, we are looping through this entire array only one time, which is going to give a complexity of big O of n. And then inside that array also we are going to kind of loop through while loop. So it is going to have, in the worst case, right, our time complexity would be big O of n square, and in the most average cases it would be n log n. In that region our time complexity is going to be. So now that's all for this video, and see you in the next one.